Hi Year 10, hope that you're all managing to stay safe and on top of your work after our return to homeschooling from the Easter holidays. Today we're going to be continuing with our work on waves, which you can find in your knowledge organiser, and reminded that that is Year 10 P8 waves that we're currently looking at. And we're actually going to be focusing on reflection in today's lesson. Now, reflection is something that most of you will be familiar with, whether that is from your everyday life or if it's to do with the fact that you met this topic in Key Stage 3. It'll all give you a really good ground for what we're going to be looking at in today's actual little topic. Let's get started then. First of all, what I'd like you to do is I would like you to have a go at this knowledge retrieval. Ideally, it would be good right now if you can pause your video screen and spend 2 minutes looking at these 4 questions, trying to give them an answer, and you'll do that without looking at your notes from last week or any information in your knowledge organiser. So pause this screen right now for 2 minutes and then come back and we'll go through the answers. Okay, so you've hopefully paused that and come back now. Let's have a look at these answers. Remember to self-correct them in your green pens. Question number 1 asked you what the electromagnetic spectrum was. So from last week's work, you should have remembered that the EM spectrum is the range of all types of EM radiation, and it's organised according to their wavelengths and frequency. Question number 2 has asked you which part of the EM spectrum has the longest wavelength. That's the radio wave portion of the EM spectrum. That's where you've got wavelengths of roughly somewhere between 100 metres and 1 centimetre. Which part of the electromagnetic spectrum has the highest frequency is what question number 3 has asked you. Well, that's the gamma waves portion of the EM spectrum. And then question number 4 asks you which part of the EM spectrum can humans see in, and that is the visible light portion of the EM spectrum. Give yourself a mark out of 4 and continue to practice those questions if you got less than 3 out of 4 correct. So a lot of the time in your GCSE questions, you will be asked about reflection in terms of light in the visible light section of the EM spectrum. You already know that light is made up of waves. So if we have an object like our light bulb that emits light, you know that the waves will be emitted, and as soon as they hit some kind of barrier, they can be reflected back. So there's our wave being emitted from our light bulb. Here is a barrier. When that light ray hits that barrier, it will be reflected away from the barrier. Now, how well or how poorly that ray is reflected from that barrier depends on the surface of the barrier itself. So for example, if we've got something that is nice and flat, smooth and shiny like a mirror, it's going to reflect that ray really well. If it's something that's dull and uneven, then it's not going to reflect the ray very well at all. But we'll look at that in a little bit more detail later. On top of that, what you'll normally have to look at in your GCSE exams is the construction of ray diagrams. Now, it could be that you are asked to complete and draw your own ray diagram for a reflective situation. You might be asked to interpret one, or you might be asked to finish one off. But it is going to be really important that you know how to draw and how to go about looking or interpreting ray diagrams. So let's have a look at how we'd set this up. So for reflection in the GCSEs, a lot of the time they're going to be talking about mirrors or surfaces that reflect something really well, like some water or a block of glass. That mirror, you don't have to get anything artistic, you don't have to be too artistic about it, you're just going to draw that simply by drawing a line. And normally indicate that it is a reflective surface by putting on a couple of lines like this. That's kind of like the back side of the mirror. And then we label it just to make sure that people understand that that is our mirror or our block of glass or our water surface, whatever it is that you're looking at in this instance. Okay, so that's the first part of your ray diagram, is establishing which thing is going to be reflecting the light. Then you are going to start looking at something called the incident ray. So that is the light ray that is coming from a light source. So we could have a light bulb down here somewhere, and it could be emitting a light ray. That's going to be incident, or it's going to be incoming onto the plane of the mirror. So the way that that is drawn is, again, just by simple line. And we know that it's an incident ray because it's going into the mirror, which we indicate by drawing our arrowhead pointing towards the mirror. So that is our incident ray, which we call I. Then we know as well that from the point at which that incident ray hits the mirror, we're going to have a reflected ray that comes back out the other side. Now, what we want to establish is that point that it hits the mirror. So we do that by drawing something called the normal line. The normal is a really important line, and it's at right angles, or it's perpendicular to the plane surface that is the reflective surface. So in this case, it's the mirror. So let's draw our normal line on there as well. That's the normal. And you can see that it would be at right angles to the mirror surface. Now that's a really important line, because that is where you would measure any angle that you are taking on from either the incident ray or the reflected ray. And that's going to become really important when we have a look in our next slide at the laws of reflection. So our incident ray has come into the block, it hits the mirror at that point there on the normal line, and it's going to be reflected off up this way, which we will draw again, just using our nice line. That's our reflected ray. We indicate that it's coming away from the mirror, so therefore it's being reflected by having our arrowhead pointing away from the mirror, and we call that R. And then we also have these two important angles that we need to measure as well. So if you were asked, or if you were given a question that was this diagram here, and it might ask you to measure the angle of incidence and the angle of reflection, then the angle of incidence is always measured from the normal. In fact, all of the angles are measured from the normal. None of them are measured from the mirror to the line. So you always must go from that normal line. And that's the angle of incidence. And that is the angle of reflection. One of the most important laws in our waves topic is this one, the law of reflection. So we saw in our last slide that we wanted to set ourselves up with a nice ray diagram. Now we've got our ray diagram, and a question might ask you to find the angle of incidence and also find the angle of reflection. So we want to know how on earth we'd go about doing something like that. Now we saw in our last little slide that ideally we always want to measure, not ideally, in fact, every single time, we want to measure our angles of both incidence and reflection from the normal line, which is this line here that is running perpendicular to our mirror. So we would take our protractors and we would measure this angle here, which we will call the angle of incidence, and this angle here, which we call the angle of reflection. Now we would do that using our protractor. Once we've found those angles, what we should know is that those two angles are actually equal to one another. And that would be true for any ray that we were shining at a plane mirror, because that is the law of reflection. So formally, the law of reflection states that the angle of incidence is equal to the angle of reflection. So really quickly, if you were given a question with your mirror, there's your normal, there's your incident ray, and you were told that that angle there was 50 degrees, and then you had your ray coming out the other side here, and that's the reflected ray, and the question asked you to state the angle of reflection. Then you know that because the incident ray has an angle of 50 degrees, then the angle of reflection is also going to be 50 degrees. So quite simple. Sometimes you might have to take it one step further and you might have to find the incident ray yourself, in which case you're going to have to use a protractor. You can see the attached sheet for how you would use that measuring your use your protractor to measure that given angle. So now it's your turn to have a little go at some questions. So you can pause the video and you can use this time to either copy the diagrams or just try your best to answer the questions to these in your exercise books. Question 1, you have a ray diagram showing you that you've got an incident light ray being shone upon a plane mirror at an angle of 28 degrees. So you need to use what you know about reflection to find the angle of reflection. Question 2, you've got very similar, except this time the incident ray is at a slightly different part compared to our previous examples. This time our incident ray is being shone at an angle of 32 degrees to the normal line. So again, find out what the reflected ray is. Question 3 is a little bit different again. This time we don't have an angle for the incident ray, but you're told that the reflected ray comes at an angle of 47 degrees to the normal, so it wants you to find the incident angle. Take some time now to pause and work through those 3 questions, and then we'll go over the answers. Okay, so question 1, these are your answers. Remind to self-assess in your green pens. If you've got an incident angle of 28 degrees, law of reflection states that the reflected angle has got to be equal to the incident angle, therefore the reflected angle is also going to be 28 degrees. Question 2, we're going to use that same knowledge once again. This time we've got our incident angle is 32 degrees, therefore reflected angle is also going to be 32 degrees. And then finally, question 3, our incident angle we don't know the angle of, but the reflected ray has an angle of 47 degrees, therefore the incident angle must also be 47 degrees. So up until this point, we have been concerning ourselves with nice typical reflection, a reflection that occurs normally at a smooth boundary like a mirror. So when we've been looking at our mirrors, we've been drawing them as nice straight lines like so. And our light comes into the mirror, it's incident on that mirror, and it's reflected off like so as well. What we're looking at here is essentially that mirror is reflecting light rays without scattering them. That means you can see a nice clear image when you look into the smooth surface of a mirror. Any reflection that happens on a nice smooth surface like so is what is called specular reflection. And that's because the light rays are always reflected in a single direction. They're parallel light rays that get reflected from that smooth boundary in a single direction. If we have another type of surface, one that is quite rough and bumpy, like so, because remember, pretty much everything in our universe reflects light. There are only a certain couple of bits and pieces in our universe that don't reflect light, so they'll either happen in this specular reflection ray or like we're about to describe. So if we have our light incident on our bumpy and rough surface, once that light ray hits a bump or a rough part, it's going to be scattered in a different direction. So it could be scattered like that. It could be scattered like that. It might be scattered like so. And then you see that we have this very diffuse reflection that is happening here. And in fact, that is what we call this type of reflection. It's diffuse reflection. So this is when we have light incident on a rough surface that becomes scattered due to the unevenness of the surface itself. So if you've got a table, for example, that's quite dusty, the dust has caused the table to have a very uneven, rough surface. If you polish the surface of it instead, then you might get to the point where you can actually start to see a nice clear reflection. It might become a little bit more like our specular reflection. So objects that have smooth and shiny surfaces will reflect in the manner of specular reflection. Anything that is rough or uneven or is coated in some sort of substances that causes it to be rough or uneven is going to give us this diffuse reflection. That ends our small video on reflection. You can use this to make notes, you can help it to make your flashcards, and you can certainly use this PowerPoint to help you answer your questions on reflection.